Okay, hello. Today I'd like to go to stress sections. First, I would like to introduce the stress which we studied last week. And again, the stresses are defined in a body at a point. Now to express that stress at a point, we define a stress matrix, which is a second order tensor. In 2 dimensions, so we need to have a 2 by 2 matrix, and in 3-dimensional case, we need a 3 by 3 matrix, again, to indicate the stress at a point. Now, one of the most important part of the stress is the symmetric to meet the moment equilibrium. So in 3-dimensional case, there are 3 by 3 9 component, but they need to be symmetric so that only 6 components are independent. And one of the most important point in stress definitions, again, defined at a point, we need to be able to transform the stress. Again, we have to be very careful about the definition of stress transformations. The meaning of stress transformation is that, let's say there is a stress defined at a point, and if we use the coordinate like this, x and y, the stress at that point would have the component like this, 2 by 2 components. And the meaning of each component is like this. Say x plane, we have a normal sigma xx, and sigma yx is a shear stress component, and the y directional plane, and then now sigma yy indicate the normal, while sigma xy is a shear. But to indicate that stress, we could use a different coordinate system, which is in this case the x prime and y prime, and very similar to the definition of this stress in xy coordinate. We have a sigma x prime normal stress to x prime plane, and sigma y prime x prime, and other plane which is the y prime, and we have a sigma y prime and sigma x prime y prime as a shear component. Now, the stress transformation is that how to obtain this stress component from original coordinate system. Let's say xy is the original coordinate, and x prime y prime is the new coordinate, which is in this case rotate and by theta degree. I will indicate it here again, theta, same theta here. Now so this new coordinate component, 4 components, will be a function of theta in terms of this stress component. So we went through derivations using force equilibrium in x prime and y prime directions, and then finally here is the a summary. I summarized the result: stress transformation. sigma x prime and sigma x prime y and sigma y prime and y prime x prime. There are 4 components, 1, 2, 3, 4. Now here, 4 components in terms of sigma xx, yy, and xy, and yx. And of course, it's a function of theta. And here, we already know that the stress are symmetric. So as you can see here, sigma x prime y prime and sigma y prime x prime, they are all same. So actually, we don't need to consider the last terms. So we only need to consider these 3 terms. And sigma xx, yy, and sigma xy, and sigma xx, yy, and xy, and sigma xx, yy, and sigma xy. So this is the equations, final equations, which we need to understand and memorize. If I summarize in a little different form, sigma x prime and sigma, I will write down y prime first, y prime, and then sigma x prime y prime equal. Now there is a cosine scale and sine scale. I will just use C for cosine. So C scale and sine scale, I can write down S scale, and twice of C times S. What I'm trying to do is that to express the equation using the matrix form, and sigma x prime and sigma x prime y sigma sigma xx, sigma yy, and sigma xy. And the second row is the minus C times S and sorry, this one is the second term. Sigma y prime is that S square and C square, and here minus twice of C times S. And third row is the minus CS and CS, and then the last one is a C square minus S square. Okay, so this is the final equations. And then again, the function of theta, and we need to understand this meaning, and it would be nice to visualize this behavior. So again, this is the stress transformations. And at this point, I would like to help you to visualize the behavior of this stress component. And to do so, I will use a Excel to plot this value. Let's say I will copy this final form. Let's see. Okay. Okay. Now this is the equations, and I will use the Excel. I will try to show you how these values are varying as a function of theta. Say what I'm trying to do is that we're gonna use this as the theta, okay, as a and theta, and then I will say this is a stress x x prime, okay, xx, but this will call prime, okay, and then x sigma, I will just assume x sigma yy and sigma xy. Okay, so this will be a theta, and this will be x sigma x prime and y prime and x prime y prime. Now, given stress, I will call, okay, I will call, as you know, the Excel is a very powerful tools, and for almost all kinds of engineers, and I strongly recommend you to use Excel. Now, let's say 100, and then I will assign a name, okay, assign name from top row. Say yes, what does it mean is that this one is now has name sigma sxx, and this one has the name syy. Naming each cell is very critical in Excel, very useful, and 0 now has the sigma xy. Now, in here, we can name for each row, let's say this much. And assign name from top row. By doing so, as you can see here, from here to there, it has a name, theta. This is indicate the name. And from here to there, it has a name and sigma x prime. Okay, so now let's say sigma theta 0, starting from 0, and then increase by 10 degree, and we can simply copy and paste, and we can have 150. Let's say we have 3 more. So that we can have a 0 to 180 degree. Now, from this equation, sigma x prime equal what is that? Cos theta. Theta now, as you can see here, is this one has the theta, and theta theta square. So we need to square of this, and times sine theta square and then times sigma xx plus, I will just copy these terms and then assign and assign, right? And then sigma yy plus twice cosine and sine. So we don't need to have a square here. And now we need to have a sigma xy. Okay. Let's check the equations. And this again is equation is sigma x prime. These are first equations. Okay, sigma c and sine oops, cosine square. Okay, I need to delete this part. And sine and cosine sine. Okay, but the theta now has to be a radian, of course. So I will change this theta as okay. I will do this way. I will do this. We'll call a radian. Okay, radian. Well, there is a simpler way. This one, instead of a theta, we can change to a radian. Radians. Okay, and like that. And radians and theta radians theta radians and theta. Okay, so say this is a 0 and this is a sigma x prime. Now we can simply copy and paste to here. And as you can see here, how equations are vary. Notice that each column, the theta is now changing from 0 to 180, and this is a value automatic changing. So if we select this value, and then let's try to plot. Okay, this is the sigma x prime. As you can see how values are varying for these three component of a stress, sigma, x prime, xx, yy, and 0, 0. If we have other component, well, as you can see here, how this component automatically changes, and as you can see here, the Excel is really powerful and help us to visualize all the values, how these values are varying, a function of theta. Okay, now the sigma x prime and y prime, we can do a very similarly. I will enter here, and then I will define a radian as another variables, and okay, I will do even simpler, just sine and cosine. And what I'm trying to do is to make a little simpler equation, nothing special, and cosine, and copy and enter here, equal cosines. So this will be will have a name, cosine, cos to indicate cosine, and here sine. That's it, and then we give a name for this much row, the column, and create like that. Now instead of this, now we can say instead of that, we can say cos, much simpler, and instead of that, we can say sine, and here cos, here sine. Okay, so if you click this one, the cos comes from here, and sine comes from here, and sine now has the meaning like that, and cos has a meaning like that. Now, as you can see here, it's much simpler. Let's copy this whole thing and put it here, and again, this equation, okay, this equation is still does not change. Now the sigma yy comes from here. Sigma yy. I'm sorry, y prime. I will copy this equation, paste to here, and as you can see here, the sine and cosine they are now changed. So I will enter sine here, and here we have cos, and now here minus. Okay. So I will zoom. And then for sigma y prime, SC, CS. Okay, so I can say S sine and cos, and we have a minus. Copy, and we have a sine, cosine, and then here plus parenthesis and cos square minus sine square. Okay. So that is the sigma x prime. Again, if we check again, sine, cosine. Okay, I will put it this so that you can see that what I entered. Minus sine, cosine, well, cosine, sine, and plus sine, cosine, sigma xy, yy. And plus cosine and minus sine and sigma xy, right? Okay. Once you enter, you can copy and you can paste. Again, you can just select this one and select that part, and you can plot them. You can see how the values are varying. Of course, this sigma x prime is the same as that one. And this is the function of theta. And let's double check for the case 0, 1, 0. Okay. Well, let's start 1, 0, 0. 1, 0, 0, 1, 0, 0. Okay, 1, 0, 0. Now at the theta 0, well, it should be same as this 1, 0, 0. So 1, 0, 0. And then for each angle, you can see that sigma x prime changing to 0 at 90 degree, and then sigma y prime is changing from 0 to 1, and then going down, and this one goes up. And as you can see that how these shear stresses are changing, I will change this value, range of a value, the major, say 45, and so that we can see from a maximum is 180, 80. Okay, looks a little better. And we don't need this. Okay, I will save this one as the well, I will save. Oops, save as. Okay, where should I save? Okay, where are the classes? Transformation, stress transformations, and 2017. Okay, so this Excel, I strongly recommend you to learn how to use Excel, and this Excel worksheet you can easily program, and this is the one of the homework this week. I will explain a little bit more tomorrow, but again, and this is the homework. Okay. Let's get back to stress transformations, and then now you can see that the stress, these stress transformation equations is convert into a different form. Okay, different form, the same equation but different form, using instead of a sigma cosine scale, we do know that, okay, cosine scale is the same as 1 plus cosine 2 times of theta divided by 2, and this is the sine scale, and defined like that, and twice of the sine and cosine, and which is the sine twice over theta. Well, I'm sure you do know these conversions. And now from this, say sigma xx divided by 2 and sigma y divided by 2 comes from here. And then the other one, cosine theta and minus cosine twice theta. Now put it here. And cosine theta, and then sine theta. Well, similarly, we also convert sigma y prime as like this, and here, and there is a sigma yy and sigma yy. Notice that there is a plus, and there is a minus and minus. And sigma yy, okay, sigma yy, we have these terms. There is a minus, and this is the sigma xy. Well, this term, again, is the same as this equation, but a little simpler, not much, but a little simpler. And also, let's try to program this one. Okay, let's start to program this one. I will copy these terms into Excel, back to here, okay, and then I'll write down here. Okay, now this term, instead of these equations, now we have a little different form. Okay, a little different form. And let's say we can enter 2 columns. And here, let's say we have a cosine twice of theta and sine theta. Okay, I will start with cosine first, and then this, and I will just say cos 2 and sine 2. And this one twice, okay, and this one as again twice. So the copy and paste, and I will give a name. Now, I want to change this formula. To do so, I will copy another one. Okay, I will rearrange this. I will put it here, and these 2 columns will comes to here, so that, as you can see here, this is the original transformations equation, And this one, same equation, but in terms of 2 theta. Let's see how they look like. Of course, they need to be same, but let's double check. So this one, we enter equations. So sine, pay attention here, cosine, sigma xx I will enter here directly so that you can see better. Sigma xx and sigma yy and divide by 2 times just plus, and then just copy this part and then paste, and there will be a minus there, right? And then multiply. I will just delete and cos twice. Okay, cos twice. There is underbar there is some reason. Okay, I will explain a little later. But cos 2 underbar. Okay, underbar is just a additional symbol to have an independent name. Because in name, it should not end with a number. So cosine 2 theta here, now plus what? Sigma xy times and sine 2 here. Okay, let's double check. Okay, sigma xx plus sigma yy divided by 2 plus sigma xx minus sigma yy divided by 2 cosine 2 theta and sigma xy and sine 2 theta. Okay. Okay, so now copy this and sigma yy. The difference is only the minus here and also minus here, right? And then last one, this one, there is the minus. Okay, sigma xx minus sigma yy divided by 2, and this should be a sine 2, right? And sigma and it has to be a plus, and sigma xy and cosine. Cosine 2. Okay, so enter this and double check minus cosine and sigma xx and sine and okay. Okay, so let's copy and paste. And of course, this one, I'm sure that they will be the same, but let's double check and copy this one. And use here and plot, as you can see here. See that? This plot and that plot is identical. Okay, it's the same. So I will save it. And again, what we have done, okay, we have done not much new theory. We have done is that we review this equation and we plot them using Excel. We convert that equation into using the this sine, cosine, and double theta rules, and same equation but a little different form. The reason why we convert that this stress transformation equation into here is to be able to draw the Mohr circle, which we will cover tomorrow. Okay, and I again strongly recommend you to go through the Excel and see the value, the graph yourself. Okay. Okay. So this is the what we want to cover today, and then hope you have understand, and let's see tomorrow. Thank you.